All right, we got part two. So it says once you know the common ratio, you can find any other term in the sequence. The formula can be written as an equals a1 times r to the n minus 1, where n is just a counting number and r is the common ratio. So let's just box this. This is important, all right? So this is for a geometric sequence. So write an equation for the nth term of the sequence. So we'll want to find common ratio. So I'll find the difference here. Difference here is 6. Difference here is 12. Difference here is 24. And I can already tell that my common ratio is 2, but let's just prove it. This would be 2, and this would be 24 over 12. So it would also be 2. But just don't forget these negatives. So that means that our common ratio is -2. All right, -2. Write an equation. Okay, so we need to using this, we'll write the recursive formula. So it says that an equals a1 rn minus 1. Well, we know what r is. We said r was -2, so all I got to do is do an. What's a1? Well, a1 is just the first term in your sequence, which happened to be -6. So we can put -6 here, put it in parentheses, and then our common ratio is -2. So I'll put -2 to the n minus 1, and that's it. That's your formula. So now find the 9th term of the previous sequence. So now if I want to find the 9th term, I'm just going to plug in 9 where n is. So I'll rewrite it. Let's say an equals -6, -2 to the n minus 1. And you notice how I'm writing some of these different? You can write these either way. Either way works. So I'll plug in, I want to find the 9th term. So I'll plug in a9 equals -6, plugging in 9 to the 9 minus 1 power. So this turns into -6, -2 to the 8th power, which then turns into -6 times 256, which then turns into -1536. And this is your a to the 9th term. Your a to the 9th term. Okay. All right, write an equation for the nth term of a geometric sequence, 96, 48, 24, 12, and so on. Then find the 10th term of the sequence. Okay, so again, we'll find, first thing, find the common ratio. Find the common ratio. So we'll find the difference here is going to be 48. Difference here is 24. Difference here is 12. And a lot of times you'll start picking up on patterns here. Like I already know that this is going to be 1/2, right? So I can take 24 over 48. It gives me 1/2. And 12 over 24 also gives me 1/2. So my common ratio is going to be 1/2. And I have everything I need to write a formula. So let's go ahead and do that. So I'll have an is equal to, so we're just gonna use this right here. So first term in the sequence is this 96. So I'll put 96, and then we will put 1/2 to the n minus 1 term, or power, sorry. And then what did it want us to find? It wanted us to find the 10th term. So then I can plug in A10 is equal to 96, 1/2, 10 minus 1, which is 96, 1/2 to the 9th power. And then this would be 96 times 1/512. And if you're wondering how I got that, all you have to do is this 1/2 to the 9th power is 1 to the 9 and 2 to the 9. 1 to any power is just 1, and then 2 to the 9th power is 512. That's how I got that. I'll just draw an arrow. Okay, so then 96 times this would give me 96 over 512. And if you reduce that, you get 3/16. Oh, that is ugly. So 3/16 or 0.1875. And I don't care if you leave it as a fraction or a decimal. Either one is fine with me. So this is the 10th term. All right, let's look at the word problem example. So it says a tennis ball is dropped from a height of 12 feet. Each time the ball bounces back, it bounces back 80% of the height of which it fell. Draw a graph to represent the height of the ball after each bounce. Okay, so first term, what's the first term? First term is 12. So I can write A1 is equal to 12. Let's try and find some of these next terms. I already know they gave us what the common ratio was. The common ratio is this 80%, or 80% as a decimal would be 0.8. So if I wanted to find the formula, this would be AN. First term is 12. So I'm going to put 12, and then my common ratio is 0.8 to the n minus 1. And then we can start solving for other terms. So let's find A2. Well, A2 is going to be 12, so it'll be 0.8. And then I'm just going to plug in 2 here. So 2 for n. So 2 minus 1. This gives me 12 times 0.8 minus 1. Or 2 minus 1 is just 1, sorry. And this is going to give me 9.6. A3 is going to be 12 to the 0.8. 3 minus 1. 12.8. 3 minus 1 is 2. Put that up there. So 0.8 or 0.8 squared times 12 gives me 7.68. And then A4 is 12.8, 4 minus 1, which gives me 12.8 to the 3rd power, which is 6.144. All right, so then I'm just gonna go ahead and write down the rest of the answers so we can graph it. So this was 4.9152. A6 is 3.93. A7 is 3.14. 8 is 2.51. A9 is 2.01. And A10 is 1.61. All right, so then we graph these. This is the first one was actually 12. So come over here. 12 would be somewhere, so it's 10, 11, 12 somewhere up here. Now 0.96 is, or 9.6, excuse me, somewhere around here. 7.68. 6.14, 4.91, 3.93, 3.14, 2.51, 2, and 1.61. So we get something that looks like this. And you can see it's gonna slowly pan out until it just hits the ground. And then it's not bouncing anymore. So that's what your graph should look like. All right, I am gonna do one more part because this is getting kind of long and I don't want it to cut me off.